So I'm recording, so anything you say can and will be held against you. You have the right to remain silent. But anyway, I'm going to just use this time to record, and I'm going to talk about, and then we can always get back and redo it. So last time we talked about the concept of number of moles. Number of moles, here's the symbol for moles. We do a little mole sign, equals mass over molar mass. Okay, so we talked about moles is the mass over the molar mass. So what is the molar mass? The molar mass is if you go to your periodic table and you look at that atomic mass number and you put it in grams, that's the molar mass. So if you've got, say the molar mass of carbon is 12, and you've got 6 grams of carbon, but not 12, you've got half a mole. Okay, so you put the mass, which is 6 grams, over the molar mass, which is 12, and you get a half a mole. Okay, and then we also talked about the concept of concentration. Now, I didn't have a symbol for concentration, but I thought this is concentration. How much you can squash into an area. Okay, so this is, if you're watching, this is the symbol for concentration. So we're developing our own sign language in science. Wouldn't that be fantastic? Concentration is moles per decimeter cubed, and that's the symbol for volume. Okay, so what is concentration? It's moles per decimeter cubed. That's on your BFF, or best physics friend. That's on your data sheet. And then 2 other numbers which you've got to know. You've got to know 22,4 decimeters cubed is 1 mole of a gas at STPs, standard temperature and pressure. So here's a milk bottle. It says here 2 liters. And a liter is a decimeter cubed. So this is 1, 2 decimeter cubed. And if you line up 11 of these bad boys in a row, you've got 22 liters. And then you line up another half of one, you've got 23 liters. But you don't want a half one, you want 22.4 of these. So you line up 11 of these, that's 22 liters and another 0.4 of a liter. And then you've got inside here a mole of gas molecules. Now, wasn't that much easier than starting to count 1, 2, 3 till you get to 27,000 billion, and then you finally get to 6,02 times 10 to the 23. So we don't like counting out molecules because we can't see them, and also takes too long. So we rather, if we're talking about a mole of any gas, we just get 11 of these bottles, and that inside there is a mole of gas molecule, nitrogen, oxygen, and a bit of carbon dioxide. Okay, so there's 22 of those equals 1 mole of a gas. And if we want a mole of a solid or a liquid or something else, we just weigh it out. So for example, if I wanted a mole of aluminium, I'm just going to share this for a moment. I go to my periodic table, and I go to my periodic table and I look for aluminium. Now, aluminium is in this group 5 here. Okay, and it's got a mass of 27. So I'm just trying to see if people can see me. There's a photograph of something, but I can't actually make out whether my group can see me. I'm just going to have to carry on. Okay, so there's you see that approximate relative atomic mass. We just call it the atomic mass of aluminium is 27. So if I want 1 mole of aluminium, I just get 27 grams of aluminium. 27 grams. Now, a chocolate bar is 80 grams. So it's about 1/3 of a chocolate bar's worth of weight of aluminium would be a mole of aluminium. Okay, so this then is the way that we find a mole of aluminium. So I'm going to need some aluminium, and let's just see if we can find iron, Fe, anywhere here. I should have looked beforehand. Where's Fe? Fe, Fe, iron, I don't see you. Come to me. All is forgiven. There we go. Iron, look at that. 56 is the molar mass of iron. It's approximately twice as much as the molar mass of aluminium. So there's iron 56 and 27. Okay, at least I know where to find iron in future. Smack in the middle of these transition elements here. Okay. So you'll be able to find the molar masses of everything here by just looking at that number on the bottom of this particular kind of periodic table that you're going to be using at school. So let's just stop sharing again. Okay, so we've got then 22,4 we've talked about, and then Avogadro's number was 6,02 times 10 to the 23. And if you count that number of particles, you stick them into that volume, you go, that's a mole, that's a mole. If that's gas molecules, and if this is mole of anything, golf balls, beach, grains of sand, whatever, it's just a number. It's Avogadro's number. It's a constant. Okay. So, as I say, I can see that there says 2 people participating. I hope you can see me. I'm recording this, so you can always watch it on YouTube. If you can see me, we're going to turn to page 193 of your textbook, Study and Master. So let's just go to page 193 of your textbook. Okay. And for my grades, yeah, okay, there's the page. And we're talking about limiting reagents. And here is the thermite reaction. And in the thermite reaction, 20 grams of aluminium are mixed with 65 grams of iron oxide and ignited. Determine which substance is the limiting reagent. Now, kind of, where's my periodic table? I should have one somewhere here. Because I've already forgotten. I remember that aluminium was 27, but what was the iron? It was 56. Okay, so I can see that I've got nearly 1 mole of aluminium and I've got 65 grams of iron. So that's already more than a mole of iron and less than a mole of aluminium. So if you went immediately to your periodic table, it says determine which substance is the limiting reagent. Oh, sorry, this is iron oxide, 65 grams of not iron, but iron oxide. I'm very bad at reading. So in the thermite reaction, 20 grams of aluminium are mixed with 65 grams iron oxide and ignited. Remember, with a sparkler. Get out of Dodge, don't stand around, close. Okay, so the step number 1 is write down the balanced symbol equation. So look, they balanced it for you. There's, you got your aluminium solid metal, 2 moles, plus iron 2 oxide solid, right? That's rust, goes to form aluminium 2 oxide solid and iron liquid. Liquid iron? Huh, strange. Huh, never seen liquid iron. Unless it was in some cold drink used to advertise iron brew. That was liquid iron. I don't know. Well, who might argue? You live and learn. Okay, but now the question really is, can you guys, if you were given this reaction, balance it? Would you have been able to put the 2 in front of there if they hadn't given it to you? And would you have been able to put the 2 in front of the iron if they hadn't given it to you? So let's just suppose we hadn't seen that 2, and it just said aluminium plus that goes to form aluminium 2 oxide. Look, when the moment you saw that there were 2 aluminiums on the right, you knew you had to have 2 aluminiums on the left. So you're only allowed to put numbers in front. Now we call those numbers in front the coefficient. And that number in front is also a mole. It's a molar number. So I think you would have been able quite easily to have seen that if you've got 1 aluminium on the left, 2 on the right of the arrow or the equation, that you've got to put a big 2 as the coefficient in front of it. Now that's the ratio in which it's going to combine. So now we've got 2 aluminiums plus, and here they give you, you wouldn't be able to work out because you don't know which iron oxide they're talking about. They give it to you, Fe2O3. So it's not like you expected to know these complicated things. They have to give it to you. But in some certain cases, like what's the ratio of hydrogen with oxygen in water, you've got to just memorize them. But this is not a case where you've got to memorize it. They give it to you. So here it says there's 2 ions on the left. So if you had gone here and they'd left out that 2 in the coefficient, you'd have known to fill in a 2 on the right. So I take it that you guys, by grade 11, can balance equations. I just take it that you can. And frankly, if you can't, it's the easiest thing and it's fun. It's like Sudoku. I think they call it Sudoku, where you play with maths numbers. I hate Sudoku. I hate maths. Okay, I better not say that. But I love physics. But this is easy balancing. Okay, so it's great fun to balance equations. So remember, we're trying to find out what is the limiting reagent. Now you're going to say, what is a limiting reagent? Okay, I'll give you an example. Say you're going to make pancakes and you need 1 cup of flour. You need 1 heaped teaspoon of baking powder. You need 1 egg, 3 tablespoons of oil, and 1 cup of milk. Okay, that's what you need. But let's suppose you've only got half a teaspoon of baking powder. That would be your limiting reagent, because now you haven't got enough baking powder for your usual recipe. You've only got half the amount. So now you've got to, because you stuck with the fact it's a crisis, you can't go out to the shops, it's a pandemic, you're stuck with this half a teaspoon of baking powder. Now you've got to reduce everything by a half because of your 1 limiting reagent. Okay, so what is your limiting reagent? The thing you've got the least of. Okay, so they want to know, and your reagents are these things you begin with on the left of the arrow. So have you got too little aluminium or too little iron oxide for your thermite reaction? Okay, that's what we're all trying to find out. So step 2, calculate the relative formula. That's the same as the atomic mass, but it's for a molecule. That means for more than 1 atom. Formula masses to find the mass equation. Okay, come on, you could have said that's surely easier. So what do? You've got 2 aluminiums, which is 2 times 27. Remember, 27 is the molar mass of aluminium. And you've got 2 of them, 2 times 27. And then you've got 2 ions and 3 oxygens of 16. You see, they put it in brackets because that's the iron 2 oxide in brackets. Goes to form, there's your 2 aluminiums again, plus 3 oxygens. There's your 16 is the mass of a mole of oxygen atoms. Okay, 3 times 16. And then you got your 2 ions, which is 55,8. So if you add all those numbers together, they have to come to the same amount on left and right. Okay, so we find out that 54 grams in a balanced equation, 54 grams of aluminium and 159, or you could say 160 grams of iron oxide or rust, goes to form 102 grams of aluminium oxide and 111.6 grams of iron. And you add that number and that number. If it's balanced, it'll equal that number plus that number. Okay, so now you know your formula masses. Al2, that's its formula mass. Fe2O, that's its formula mass. And then that's the formula mass for aluminium oxide, and there's the formula mass for Fe2, or 2 iron atoms. Now choose one reactant A and calculate how many grams of the other are needed for A to react completely. If the available amount of B is more than the calculated amount, A is the limiting reactant. If the calculated amount of B is less than the actual amount, B is the limiting reagent. Wow. Okay, so what did they do? You were given 20 grams of aluminium over their that formula mass times 159,6, which is that, equals 59 grams of iron 2 oxide. So what they're saying here is that in theory, you only need 59 grams to match that. But let me tell you what they're really doing. They're taking mass that you're given over molar mass. They're working out how many moles of this we've got, and they're multiplying it by that, and how many moles of that are needed, and the molar mass of that. But they're saying that 65 grams of iron 2 oxide is available. So that is bigger than that. So it means that aluminium is the limiting reagent. Woo! We could also do it the other way around. Okay. I'm going to do this on the board, I think. So let me just stop sharing here. How do I get to stop sharing again? How do I get out of here? I've lost my Zoom page. Oh, there. It should be somewhere here. Can anyone see me out there? Yes. I can see you. You just have to switch on the video.